All right, we're going to pick up at number 10. Let me flip this into tablet mode here. You'll notice that in the review, 10 is discrete random variables, and it looks like the first three are some nice charts that go over the probability density function. And so I'm just going to read it out loud. It says 10, given the probability distribution for the indicated random variable, 3 fair coins are tossed, and x is the square of the number of heads showing. X is the square of the number of heads. And so what I'm going to do first is we're going to just say, well, what are all the possibilities if we have 3 fair coins, and I toss the 3 fair coins up, right? I have a possibility of getting 0 heads out of the 3, 1 heads out of the 3, 2 out of the 3, or 3 out of 3, right? Those are my 4 options. Now in this problem it says, well, we're going to take all these numbers and we're going to square them. Right, so if I square them, my x values here are going to be 0, well, 0 squared, 0, 1 squared, 1, 2 squared, 4, and 3 squared is going to be 9. I'm going to grab these really quick and bring these down here, right? So they really try to confuse you. Really, even though we're squaring these numbers here, we're really actually interested in the probability of these, right? They're going to be identical. All we did was square the numbers, right? So the probability of getting 0 heads, right? Well, that means 0 heads. Well, let's think of what happened. That means you got a tails, 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 right? And there's only one way for that to happen. So we have 1/2 times 1/2 times 1/2. And so down here, 1/2 times 1/2 times 1/2, this is just going to be 1/8. Now for 1, right, so I'm going to reference these numbers up here for the probabilities. It's going to make it a little bit easier. For 1, right, that means we could have heads, tails, tails. We can have tails, heads, heads. Tails, heads, tails, and tails, tails, heads, right? And each of these, so there's 3 different ways for this to happen. And again, these are all going to be, well, 1/2 times 1/2 times 1/2. Let's write it below, right? There's 3 different ways here. And the probabilities are 1/2 times 1/2 times 1/2. Right, in other words, right, each one of these has a 1/2 times 1/2 times 1/2 probability. And since there's 3 of them, right, we're just going to multiply that by 3. In which case we get 3/8. And we could do this for 4, right, or in other words, 2. So now 2 tails, but what we would see is you could go through the same process. You would end up with the same thing, also 3/8. And the last one, how is there? There's only one way to get 3 heads, right? They're all heads. And so it's going to be 1/8. Right, so never be, if you have time, right, you can obviously just write out all your possibilities here. Again, if you're flipping a coin, there's 2 sides, so the probability of a heads or a tails, right, each individual one is 1/2. Okay, let's go to number 11. So it says 11, let x be the upper number, right? We went through this one of the 2 dice that are rolled, or the common number if doubles are rolled, right? So if you have a 4-3, it would be a 4. If you had a 5-5, it would be a 5. Right, so for this, if you do have a maximum or minimum number problem, it's just going to be easiest to draw these all out, right? So you have 6 numbers here, and we'll fill out the chart in a second. And you're looking at the other 6 numbers, right? So 2 dice, and you're taking the maximum. So in this case, right, maximum is 1, and then the chart gets filled out like this. So there's going to be 36 possible options here, right? It's a 6x6 matrix essentially. And then you can count them up, right? So if we're looking at, well, we have the x values up here, and our possibilities are 1, 2, 3, 4, 5, and 6, and there's 36 possibilities, right? So our probability of x equaling x. Well, for 1, that only happens one time. I could have spaced these out better, sorry. Let's go ahead and zoom in. Right, 1 only happens one time, so it's 1 out of 36. Let's go ahead, I'll erase to give myself some more space. If we're looking at 2, let's go ahead and look at our chart. Again, there's 36 possibilities. Here are 2's. There's 3 of them. If we're looking at our 3's, right, there's 5 of them. And so maybe you'll see the pattern here. It looks like every time we do this, we're just going to add 2 to the numerator, right? Let's double check last time. 4, and 4 of them here, so 7 total. And so the pattern is 7 over 36, 5 is going to be 9 over 36, and 6 is going to be 11 over 36. And again, you should be able to add these all up, right, and they should be equal to 1. Right, minimum is just going to be the inverse, right? In other words, instead of 1 being 1 over 36, 6 would be 1 over 36, and vice versa for everything else. Okay, let's look at 12. It says a random variable x has a probability distribution table as shown. Okay, and again, we need this. We need to know that the sum of all the probabilities should be 1. Right, so in our chart, I'll write it out what they have. Right, they have 2, 4, 6, 8, and 10, and they've given you these numbers. And then they told you that the probability of x equals 6 is equal to the probability of x equals 8. And which means that right now, if I add up 0.1 plus 0.3 plus 0.2, I get 0.6, which means there's 0.4 left over. And if these two are equal, that means each individual must be 0.2. So this is the first step. It doesn't tell you to do this, but you need to do this in order to actually solve for the rest of the problem. In part A, it says find the probability. Let's actually write this correctly here. That x is going to be between 2 and 10. Now, something key to mention here is that notice on these inequalities, there's no equals, right? So we don't want to include 2 or 10, meaning we just want what's in between, or the 4, 6, and 8. Right, so we just really want the probability of x is equal to 4 plus the probability x is equal to 6 plus the probability x is equal to 8. And so we get 0.3 plus 0.2 plus 0.2, or 0.7. Now for B, it says the probability that x is less than or equal to 6, right? Also known as the CDF here. And so we're just going to go to 6, which is 0.2, right? And we're going to add everything below it, and which we get 0.6. So those aren't too bad. Give me a second, I need to scroll down here. I have a double screen up here, so I'm trying to scroll through your review, in which we enter the binomial distribution. Okay, so let's scroll. Let me go back to your review here, sorry. Binomial distribution. And I'm going to see, I think I have the calculator. So it says let x be a binomial random variable. I'm just going to label what we have for information. And then I'll write down the calculator code here. So n equals 7 and p equals 0.1. And we are interested in exactly the probability x is equal to 5. Okay, let's see. I think I should have this. I might need to go download. I put in the ROM. Yep, there we go. Boom. Let's put the OneNote back. We'll minimize this and we'll pull open this. There we go. There we go, that's better. Okay, now let's remind myself. I believe I go to Stat. I want to go over to Tests, I think. Not. Maybe not. Let's try another way. Maybe it's second. It's not second stat, is it? Bars. That's right. Second bars. There we go. Distributions. And so now we're going to go look for, in this case, since it equals, right, it's equal to 5, we want what's known as the PDF, the probability density function, at a specific value, which in this case is 5. So let's click enter. It says trials, which is n. We have the p, which is the probability of success, in our case 0.1. Our x value that we're interested in is 5, and we paste it. And so you can see that the function here is binom PDF. Binom PDF, and I'll write this out in a second. Oh yeah, so then we have to do this trick, right? We're gonna add 1. So we can actually see the decimal because it wants us to round to 5 decimals. So we have 1.001, so we're interested 3 zeros and then 1701. 3 zeros, 1701. And I'll write down the function so we have it here, but we're going to use it a few more times. This is binom PDF, and this is n, probability of success, and the x value that we're interested in. It does say to use the formula, so if it does say to use the formula for a probability of a binomial distribution is going to be, I'll leave it as an x, but normally you would see it denoted as a k. It's going to be n choose x, probability of success raised to x, and then the probability of failure raised to n minus x. So in this case, it looks something like this, which would be 7 choose 5, so this is a combination here. This would be 0.1 raised to the 5th power. We have 5 successes, right? So it has to happen 5 times. And then we fail twice, right? So failure is the complement of the 0.1, which is 0.9. And out of 7 times, that would happen twice. So this is telling you, this number here is telling you all the possible ways that this can happen as far as the arrangements of these successes and failures. And this is the actual probabilities that are occurring. Right, but this is the calculator. This will allow you to check, or if he wants you to use the calculator, you can just fairly use the calculator. Okay, 14, it'll be another binomial distribution. It says if you roll a fair die 8 times, so n is equal to 8, what is the probability of throwing at most 2 6s? So at most 2, meaning x is less than or equal to 2. And now if you're rolling a 6 on a fair die, the probability of success is 1/6. And so we're going to be looking at binom, and because we want less than or equal to, right, it says at most, so we do want 2. Binom, we want CDF, and it's going to be 8, 1/6, and 2. But we're going to pull that up on the calculator here so we can see it. Oh, where did it go? Looks like it exited out. I got to do this again apparently. Sorry. At least I know where I'm going now, right? We want to go second vars all the way down. Apparently I can't click very quickly. Almost there. Binom CDF. We have 8 trials. We have a p-value of 1/6. Oh, it doesn't let me do that. And it has an x value of 2. And in this case, we have 0.86515. Does it say how many decimals? It does say rounded 2 decimals. So 0.865 is what we're looking at here. 0.865. All right, and moving forward, 15. It says, according to a study, the probability that a randomly selected teenager studied at least once during the week was only 0.52. So it looks like our probability of success here is 0.52. The at least here doesn't matter. Let X be the number of teenagers who studied at least once during the week. Okay. What is the probability at least 5 of the students in your group of 10? So n equals 10, and then it says at least 5. So it could be 5 or more. So X is going to be greater than or equal to 5. Now, when you're doing binom CDF, it only gives you less than, right? Less than or equal to. Now, because this is a discrete probability, instead of finding the probability X is greater than or equal to 5, this is the same thing as 1 minus the probability that X is less than or equal to 4, right? And this is the value that you could get from the binom CDF. And so what we're looking for here is we're going to be looking for 1 minus binom CDF of 10, comma, probability of success is 0.52, comma, 4. Right, we're doing 1 minus this. So let's go ahead. We're going to jump back to the calculator, if I can find it. And so let's go ahead, let's clear this out. We got to go second vars. A lot of clicking, sorry about this. I'm going to memorize what number this is. I guess it's B, it's a letter. We have 10. Enter. Our probability of success here is 0.52. We're interested in 4, right? Because we're looking for the complement. Eventually we're going to do 1 subtract, or 1 minus. And this gets us a value of 0.3288, etc. But we're not interested in that, right? We want 1 minus this value. And that will get me the number that I'm really interested in, right? So in this case, 0.671. And it doesn't say, does not say how many decimals, so we're just going to go with 0.671. Okay, 16. So still more on the binomial distribution. Your manufacturing plant produces airbags and it is known that 30% of them are defective. 6 airbags are tested. Okay. So apparently in this case, defective is success, right? Kind of the opposite of what you would think. And n is equal to 6. So this is number 16. And we'll say P here is equal to 30%, 0.3. So then part A says, let's read this. A says, find the probability that exactly one of them is defective. So in this case, probability that X is equal to 1. So anytime we see the equal sign with the binomial distribution, which is successes and failures, we're going to be looking at binom PDF. In this case, it's going to be 6, 0.3, and 1. And so let's go ahead and go back. We're going to look over at our calculator again, if we can find it. All right, so again, second vars. We'll go down. Doesn't let me click a lot. Almost there. Oh, PDF, right? PDF. Enter. So we have 6. We have 0.3. And we have 1. And we press enter, and we're going to get 0.3025. How many decimals? It says 4 decimals, so 0.3025. And then for part B, let's read this. It says find the probability that at least 2 of them are defective, meaning the probability that X is greater than or equal to 2. And remember, binom CDF doesn't give us greater than. It only gives us less than. So this is the same as 1 minus the probability that X is less than or equal to 1. Right? So in other words, this is going to be 1 minus binom CDF of 6.3 and 1, right? So And in part A, it was a PDF. Now we're doing a CDF. Same thing. Let's go ahead and go back. Try to minimize so you can see the whole thing there. And let's go second vars. We'll go down here. Oh, too far. Binom CDF. We have trials, which is going to be 6. Probability of success, 0.3. And we have our X value, which is going to be 1. Enter. And don't forget this last step is going to be 1 minus this. And so, again, I think it says 4 decimals. So 0.5798. 0.5798. Good. We're going to move forward to 17, last one of the binomial distribution. It says, assume that on a standardized test, 100 independent questions, a person has a probability of 80% of answering any in particular question correctly. So in this case, n is equal to 100. Our probability of success is equal to 0.8. That's pretty high. Find the probability of answering between 80 and 90, right? So between 80 and 90. And it's inclusive. So we have 80 and 90. And I think I mentioned, right, the only way to really do this is, well, if I find the CDF of 90, right, the CDF of 90 is going to give me everything that includes 90 and below. And so if I want to find the space in between, I need to get rid of everything that is below 80. I want to include 80, right? So I need to subtract out everything that is below 80, which is a 79. So I have 2 different CDFs here that I need to calculate. All right, 90 and 79. So last time, we'll go ahead. We'll go second vars down to, we're getting there, one more time, CDF. In this case, we have 100 as our trial. We have 0.8 as success. And first, we are going to be interested in 90. And we can just enter this in so we have this value, right? And now I'm going to go do separately, same thing, except now I'm going to go type in 79 instead. I think I just need to make the one change. Right, yep, just the one change. I just need 79. And now I need to take these 2 values and subtract, right? So I'm going to go take my upper value from the 90 and subtract out my lower value from the 79. And that will give me the space in between. And I believe it says round to 4 decimals, so I got 0.5571. Let's verify all of our solutions are correct, since he was nice enough to provide the solutions. 0.5571, perfect. Let's see the other ones. 0.5798, good. 3.025 and 0.670. I wanted 4 decimals here, so this should have been a 2, but still, we still have it correct. Let's double check. 0.8675, good. And good. Okay. So let's go ahead and move on. Let's go ahead and go over to, we're on to 18, I believe, which is, I think, measures of central tendency. Should be right around that 30-minute mark again. So this is number 18, measures of central tendency. It says, after bowling 5 games in a bowling league, James has exactly 150 average. So we talked about this one, right? If you have 150 average over 5 games, that means essentially each game you bowled 150. And of course, you don't need to write this out. You could do 5 times 150. I'm just trying to do it so we have a better visual. Right, first 5 games, I got 150. It says, what does he have to bowl in his 6 games, right? So there's a question mark here. We'll call it X in order to have an average of 152. Well, for an average, that means I would take all of the games that I bowled, divide it by how many games I've bowled, 6, and I would get 152. So in our case, we have, well, 150 times 5, right? That's going to be 750 plus X over 6 is equal to 152. If I multiply both sides by 6, 912, I think sounds right. 600, 312, there we go. 912. And if I minus 750 on both sides, I'm going to get 162. And you can always just go test your answer, right? You could plug it in, make sure that you have the correct average. Okay, 19. Moving along. It says 50 darts are thrown at a dartboard. The probability of hitting the bullseye is 0.2, right? So in this case, this is an expected value problem, but it's also expected value of a binomial distribution, in which your probability of success is 0.2, and you have 50 darts you're throwing. So if this is the case, you have a very nice formula for the expected value of a binomial distribution. It's just n times p, which is 0.2 times 50, which is going to be 10. 20 says a random variable x has a probability distribution table as shown. Okay, so let's go ahead and make our chart. And again, they leave the chart partially blank for us to fill out, but it's fairly easy based on the fact that the probabilities have to add up to be 1. And so we have -2, -1, 0, 1, and 2. And they give us these values, 0.1, 0.1, 0.4, and which means we're missing 2 values, and we're also given that these are equal to each other, right? So we're missing, here's 0.6 is given, we're missing 0.4, and if these are equal to each other, they both have to be 0.2. And it's an expected value problem, so it's asking you to find the expected value here of x. Well, in our case, if you're given a table, the fancy notation here for the expected value of x is going to be the sum, right, of x times p of x, right? And if we use this for the continuous form, which we'll see later on, we'll see how the summation and the integration connect with each other. But for right now, we're doing the discrete form. And so we're just looking at these pairs, right? I'm going to take my x value, which is -2. I'm going to multiply it by the probability of getting the -2. And then I'm just going to repeat this value, and I'm going to write them vertically so it's easier. -1 times 0.2, that's the probability of getting -1. Now you can write this if you want to for completeness, but 0 times anything, right? 0 times 0.4 is going to be 0, so I'm just going to skip over it. Plus, our x value is 1. The probability of getting 1 is 0.1. Plus our x value is 2 times the probability of getting 2 is 0.1 as well. And so we end up with -0.4 plus -0.2 plus 0.1 plus 0.2. And I believe these will cancel out, and we end up with -0.3 as our final answer here. For number, let's check it. Always good just to verify. Sometimes I do these a little quick. Number 20, -0.3, perfect. And lastly, we bring up 21, which I believe is the the roulette wheel, right? 21. So it says roulette wheel has numbers 1 through 36, so there's 36 options there. It also has 0 and double zeros. So we have 38 total options. And this is the one I said to make sure you ask them about. A bet on 4 numbers pays 8 to 1. That is, if you bet $1, oh no, this was a different one. a bet on 4 numbers pays 8 to 1. That is, if you bet $1 and one of the 4 numbers you bet comes up, you get the dollar back plus you get the 8. How much do you expect to win? Now, the expectation of winning is a little bit different. Right, so expectation of winning, well, there is if we pick 4 numbers out of the 38, there is a 4 out of 38 chance that we win. And if I do win, I do get the dollar back, but that's not how much I win. I win $8, right? This is how much I win. However, there are also 34 out of 48 chance that I lose. And if I lose, well, then I lose my dollar. And so it's asking us our expectation of winning here. So this is 32 over 38 minus 34 over 38, which is just going to be -2 over 38, or -1 over 19. And so if I type this in my calculator, it looks like roughly 5 cents, right? So I think that's probably what it's going to ask. It says round your answer to the nearest cent, so I'm guessing 5 cents, but let's check. -1 divided by 19. Yeah, 5 cents. And so, but it's -5 cents, right? -0.05. Okay, so that takes us to the end of 21. So hopefully these helped. I will make videos following for 22 through 40 shortly. All right, see ya.